Hello, our viewers. Welcome back to our channel, Motormouth Uganda. We are going to talk about an interesting topic today, which is hybrid cars. Of course, cars have developed over the years, and these days there are so many other options away from what we grew up used to. Engineer Ivan Chivuka is going to take us through what exactly these cars are. We have seen some of them on our roads, or we have assumed to have seen them. Sometimes we are told this is a hybrid car when it is actually no longer using both options. But we shall find out as we go along. You're welcome.
Thank you, Alan. Fellow Motormouth, I'll get straight to business. The last part you talked about, Uganda tukuita kulawa. When the batteries become a problem and the related electronics, they get removed and you get a vehicle that's running 100% on an internal combustion engine. Yeah, but as it is moving around, you may not realize it is no longer hybrid. But today we are here to discuss hybrid vehicles so that our viewers get to understand them better, understand why they are important. And hybrids are generally a step onto e-mobility, onto electric cars. So as usual, I'm going to share a presentation that I prepared for this. I hope you can see it now.
Yes, I can see it.
Okay. Like I said, we are going to talk about automotive hybrid systems. Like you said earlier, vehicles are evolving. Used to be, we used to have Futsubishi, where people would use their legs and feet. Amagulu nga ge gakola ki? Ge gakutaasa ge galamula. Then humans moved over to using horses and mules. Some in India even used elephants and so on. And then we came to locomotives, steam engine, trains, and ships. Now we came to vehicles. The automotive industry actually liberalized or democratized transport in that individuals could now afford to travel when they wanted rather than use public means like trains and water transport was at that time. So now we are at a level where electric cars are taking over, but electric cars are taking over from hybrids because hybrids took over from internal combustion engines, 100% internal combustion engine. So a hybrid car is a type of vehicle that uses two or more power sources to drive the vehicle. So it combines an internal combustion engine, usually diesel or petrol, sometimes ethanol, with an electric motor. The electric motor is powered by battery. And this battery is charged either through regenerative braking, as we shall see soon enough, or by the engine itself, or in plug-in hybrids by wall chargers, just like electric cars. I'll explain this shortly. Hybrid cars are designed to improve fuel efficiency, reduce emissions, and provide a balance between the convenience of internal combustion engines. We all know internal combustion engines have been around for more than a century, maybe 120 years. So they are quite convenient. That's why they have lasted that long. So hybrid cars strike a balance between this convenience and the environmental benefits of electric motors, because we all know internal combustion engines pollute the environment as they drive along. There are different types of hybrid vehicles. So there is a full hybrid where the car can run on just the engine. or it will run on just the electric motor, or it will use a combination of both at the same time. The early Toyota Prius is a well-known example of this. Now, there are also plug-in hybrids. These can be plugged into an external power source. It behaves like a full hybrid, but it can also be plugged into an external power source, just like an electric car, to recharge the battery some more. This allows the car to have a bigger battery and to drive for longer distances on electric power alone before the engine kicks in, like in the earlier example of hybrid vehicles. An example here is a Chevy Volt. We don't have it, at least I've not seen one in Uganda. We don't have it locally, but I've seen a few in the US and Canada. I'm not sure if they have them in Europe, but they have other variants from other manufacturers which are plug-in hybrids. I'm just giving the Chevy Volt as an example here. And then there are mild hybrids. These have a smaller electric motor that assists the internal combustion engine, but cannot drive the car on its own. I think this is the Honda strategy, the early Hondas. This is what they used to do. They help improve fuel efficiency, but do not offer the same electric-only driving capabilities. Yeah, but they have the engine start-stop system, an advanced type of engine start-stop system. They are hybrid vehicles, but they are mild. We now have on the screen an image that shows you the main hybrid setups. You have the parallel one, where you can see the image on top, the schematic on top. This one here represents the parallel hybrid type, where you can have a battery which through an inverter will drive a motor, and through a clutch will send power to the wheels. Then alternatively, you can have the engine through a clutch, also sending power to the wheels. But you can also have this central clutch here, combining the two at the same time. Now, this is typical of the early Toyota Prius setup. And then we also have the series hybrid type, where you have the prime mover, which is the internal combustion engine, which through an alternator will develop electricity, which is sent through a power converter to the battery to charge the battery, and then through another power converter. Here, SC, because to charge the battery, you need DC, and the alternator normally produces SC. So you need a power converter to convert that AC into DC to charge the battery. But the motor also runs on AC. Usually it's a three-phase motors. Automotive motors are normally three-phase, so they need AC to operate. So the stored electrical power in the battery is in DC form. So you will need a power converter again now to convert the DC back into AC to operate the motor, which will now, through the differential, turn the wheels. And I decided to use the Toyota Prius as an example in this presentation because many of you are familiar with it, at least you've seen it on the roads. So it has two motive power sources, as I mentioned earlier, which are engaged depending on driving conditions. It has a 1.5-liter petrol engine developing 42.5 kilowatts at about 4,000 RPM and a peak torque of 102 Newton meters at the same 4,000 RPM. And we also have a battery-powered permanent magnet synchronous electric motor with a maximum output of 30 kilowatts over the speed range of 9,000 to about 2,900 to about 2,000 RPM, and a peak torque of 305 Newton meters from standstill to 940 RPM. Alan, do you notice that the electric motor is capable, although it is less powerful in terms of power, wattage, it is capable of producing a torque that is 3 times that produced by the internal combustion engine. So in short, electric motors are very efficient in that they produce torque is what you actually need to start moving. So it is a more important value. So electric motors are very, very efficient compared to internal combustion engines. And these numbers are indicating that. The petrol engine is a hybrid's main power source because the engine is a 1.5 liter double overhead camshaft 16 valve engine with a 13.5 to 1 compression ratio. This is all technical jargon, but I just need to spell it out. It also has a variable valve timing, what you call VVTI, variable valve timing with intelligence, which is a continuously variable valve mechanism, and electronic fuel injection. Is quite an efficient, in short, it is quite an efficient petrol engine, but still, it is not as efficient as an electric motor. So in starting from rest and light load mode, when you start off, especially if you are not pushing the pedal all the way to the floor, if you are starting off lightly, at low speeds, the electric motor drives the vehicle and the petrol engine is not running at all. In fact, most people, when they transit to hybrid vehicles, they are puzzled because they start the car and nothing happens. It is until you release the brake pedal and you realize the vehicle is moving by itself. That's when you wake up and realize and remember you are driving a hybrid. So the high torque characteristic of the electric motor helps to get the car moving and will sustain it during low load demand and slow speeds progress in urban centers up to about generally about 50 kilometers an hour. Should additional power be required from the petrol engine, that is, if more power is required to accelerate or to keep up high speeds, or if the battery that is feeding the motor starts running low on Gs, the computer control system will ensure that the engine will play its part. The engine will start by itself. You don't have to do anything. It will start by itself, and when it is no longer required, it will stop by itself. You have nothing to do with it except just keep driving. So it will do this either by charging the traction battery power pack or by some direct contribution to driving the road wheels. But when coming to rest at traffic lights, the fuel supply to the engine is cut off and the engine is automatically stopped. And then regenerative braking will be happening in the background. So during deceleration and braking mode, the kinetic energy of the moving vehicle passes from the road wheels through the transmission or gearbox to the power split device, the clutch, to the electric motor. This way, the vehicle now pushes the motor, it charges, the motor turns into a generator. A motor takes power from a battery to spin, whereas a generator, when it is turned or spinned mechanically, can produce power. So a motor and a generator can be the same thing, depending on which direction the current is flowing, depending on the circumstances. So the electric motor turns into an electric generator, depending on which side is loaded and which side is receiving current. So this then acts as an electric generator, which I've just been talking about, delivering this energy as a charging current to top up the traction battery pack. This feature of regenerative braking comes into play regardless of whether the driver applies the foot brake or relies on engine braking to slow down the car. I'm one of those people who uses the engine braking a lot. Even in heavy traffic, I try to use it on gradients when going downhill. A complex but compact, powerful power inverter and control unit ensure that the traction battery pack is being maintained at a constant charge. There is a lot of electronics and electric wizardry going on in the background to do this. So when the charge is low, the electric generator routes power to the battery. In most instances, this energy will come from the internal combustion engine rather than the energy recovered during braking. So yes, during braking, you recover some of the energy, but you don't recover much, but it's better than nothing. So a lot of the power to drive the hybrid, yes, it comes from the internal combustion engine, but at least it is controlled and you are able to save power that would otherwise be wasted. For example, when you are braking, that energy is converted from braking, brakes produce heat. A lot of heat is saved, is not lost. It is turned into electrical energy, which is stored in the battery. That's where the efficiency of the hybrid comes from. That's why a hybrid is more efficient than a 100% internal combustion engine. So the early Toyota Prius strategy, as we discussed earlier, here is a schematic showing the engine, which drives a generator, and the generator through an inverter will charge the battery. Now, when required, for example, when you are starting off slowly, the battery will send power, electrical power to the motor, and then through the gearbox, through the transmission here, turn the wheels. But at the same time, if the battery is low on juice, the internal combustion engine can, again, through the transmission, drive the vehicle, turn the wheels, but again, also drive the generator at the same time to charge the battery. And then this graphic represents the phases that I've just talked about, the starting part, where the vehicle is running only on electricity, the normal driving, where the electricity or the battery and the gasoline engine are contributing to the power to propel the vehicle forward. And then when you have extra loads, you have the electrical part contributing even more to overcome the higher loads. And on decelerating, the engine will stop and then the batteries will be charged. And when you stop, everything will be, everything will stop, including the engine. So now, here is an example of the early hybrid, Toyota hybrid. This is a generation 1 or 2 Toyota hybrid. Usually the battery that we are talking about, it has 2 batteries. It has the normal 12-volt battery to run the electrics on the vehicle, like the windows, lights, mirrors, everything on the car that is not related to the powertrain is run off this 12 battery. So it is similar to the normal batteries that we are used to. But the battery that is used to drive the motor for the hybrid part is in the back, as you can see. Usually somewhere in the boot or sometimes in some models under the back passenger seat. It will look something like that. And this is a closer look at that battery pack. But in this battery pack, it looks like a big unit, but it is made up of individual battery modules. The smaller the car, the fewer the battery modules that will make up the battery pack, and therefore the smaller the battery pack will be. But here, in this image, you are only seeing one battery module here, in this corner here. The others have been removed in this schematic so that you can see what else is left here, like the sensors, the cabling, so, and then the service grip, which must always be removed before you start any repairs on hybrid vehicles, on the high voltage side of things. I don't want to get too technical, but I just wanted you to have a little insight into these batteries. I want to demystify them a little bit. And they always have a battery current sensor to inform the computer how much current is going in or out of the battery. For safety and other controls, And then here is an example of battery modules, which make up the entire battery pack. So these modules will come in pieces like that. And usually people are afraid that battery packs are expensive, and they are expensive to replace when they go bad. But I just want everyone to understand that these battery packs are made up of these modules. So you can find a battery pack has failed because one or two or three battery modules have failed. So as long as you are able to fix those three, you are able to identify and fix those three battery modules, the whole battery pack can work again for another 6 months, 1 year, 2 years. Yeah, I will discuss these battery packs some more in future, but we test these battery packs and modules, individual modules for capacity um, at process control and automation engineers. We thoroughly test them. So if you have like a battery, you have an error code coming on your dashboard where it is warning that the battery is bad, you need to replace it. If you bring the battery pack to us, we can test these individual modules, identify which ones need to be replaced, and replace them with the modules which are similar in capacity to those that are remaining in the vehicle. It is not a matter of slapping new modules into the battery pack. That can actually bring new problems, new and bigger problems. So you always have to replace modules. Say you have a pack of 28, you have only 4 which are failing. The 4 which you are installing in the vehicle must match in terms of capacity, must match very closely the ones which are remaining on the vehicle. So we do all this kind of testing to match the incoming modules to the ones remaining in the vehicle. All these modules are, wired or connected in series in the battery pack. So even just one module can affect the entire pack. But I just wanted to have everyone have a better peace of mind when they are buying a hybrid cars, that they are not always expensive to repair. Once you do a good diagnosis and a good examination of the battery pack, you can solve battery issues, most battery issues, quite economically. You don't have to break the bank for this. So yeah, that brings us to the end of our of my presentation. I don't know if you have any questions.
Thank you very much for that explanation. We have always just been seeing these cars on the roads, and we didn't know the technology behind what a hybrid car requires. Some have the plugins, others, you not knowing when it takes the fuel and when it takes in the power to charge the battery, or how the battery is charged.
Mm.
We have also noticed that they have started becoming a bit popular, even in the second-hand cars that people bring in.
Mm.
I see with the Toyotas now, the logo usually is on a blue, sort of
Yeah,
a blue
there
back.
is a badge. It's a badge with
Yes.
a blue kind of S. Yeah. Yeah, you can
Yeah.
notice
So
there are a lot of Toyota Noirs, Alphard, some Mark X's, Fielders. There are many Toyota Fielders, Toyota Corollas, Axio, Aqua. Aqua, that one is a popular one. Yeah, the Prius itself. Yeah, Corollas. Yeah, they are good number. They are, and even in Subarus, the Imprezas, the newer Imprezas, and XV. Yeah, they are. We are beginning to see a big number of them being imported, used, of course, on the market.
so what generally would you say are the advantages of these hybrid cars, besides saving the environment. You know, these days there's a lot of backlash against the tree huggers and climate change advocates.
Yeah, besides, if you even set the environmental bit aside, the the fuel efficiency is high up there compared to 100% internal combustion engines. Why? Because when you are running in heavy traffic, a hybrid vehicle will normally switch off the internal combustion engine and only run on the battery. So as you are moving up slowly in traffic and you are stopping, start, stop, it's using only the electric side. And there is no waste going on because it will only drain power from the battery when it is moving. When it stops, it's not taking anything from the battery. As simple as that. Whereas an internal combustion engine stuck in traffic, even when idling, it is consuming power because the engine has to keep running and it keeps taking your fuel. The hybrid doesn't. So it helps very, very much when you are in heavy traffic because it means most of the time, if the hybrid system is working very well, the engine will only run when you are above, say, 50 kilometers an hour. When you accelerate up to 40, 50 kilometers an hour, that's when the engine will be running. Even when it runs at standstill, it means the battery has been drained and it will run only for some short time. If the vehicle is still at a standstill, as soon as the battery is full, it will shut off. Like that. It does that by itself. So it's not like an internal combustion engine where the engine keeps running until you switch off the engine with the key. So there is no two ways about it. It's a hybrid vehicle is much more economical to operate than an internal combustion engine, just by that alone. That's a major advantage. And then, of course, we shall go into the environmental advantages, but everyone knows so much about those. People who have driven hybrids in cities, I don't think it is easy to take them back to 100% internal combustion engine after they have experienced that efficiency. Even in a big car like the Alphard or the Mark X, the fuel economy becomes manageable just because the engine is not running all the time, especially at low or no speeds, like in traffic. That advantage, you can't take it away. Electric cars make that even better. Of course, there are other arguments going into the environmental side of things, the pollution involved with the manufacture and disposal of batteries. That's another topic. But on the road, let's just consider what is happening while you are on the road. You are polluting much less when you drive a hybrid than when you drive an internal combustion vehicle. And you are also using less fuel, and also they are more powerful. Because when you are accelerating, if you decided to burn rubber against a hybrid car, you may be shocked. It may have a 1.5 liter engine, it will shock you in a duel. Because it has that engine and it also has the motor. So on demand, when it realizes you are putting the pedal to the floor, even the motor will produce all the power it can, add it to the power the engine is producing, and it will show you dust. So when you get used, even on the highway, when you get used to driving a hybrid, when you go back to an internal combustion engine vehicle, it feels a bit weak. So they are a bit more powerful than internal combustion engine. So even on the power front, they are better. If your hybrid system starts failing and the engine is running all the time and you don't have the backup of the power, that is when you realize how powerful the hybrid system is, because you now realize the vehicle is sluggish. Fix the hybrid side, and then the power comes back, and you are like, oh, this is what I was missing. So that's why they have become popular, and that's why some countries have made it mandatory. no internal combustion engines, 100% internal combustion engines by this age. And then even hybrids are being phased out. In the next video, we shall be talking about electric cars, so we shall discuss that in more detail. But with regards to advantages, they are quite clear. If you are not convinced, perhaps you may need to get a test drive in a good hybrid, a hybrid that's working properly, to convince yourself that they are actually better in performance and economy than 100% internal combustion engine. And there are even hybrid cars with diesel engines. They have them in Europe. We don't have them here. Now, I don't even want to imagine what kind of power those ones are capable of, because putting together a common rail diesel engine and a hybrid system, yeah, I think only 100% electric cars can beat those, because like we shall discuss in the electric cars, it's a whole different territory over there.
I was wondering if you can put some figures, especially on the fuel economy, because you know our people are really not bothered about the environment. They would rather be told that, you know, if this car where you've been using 1 liter for 11 kilometers, you can use 1 liter for this much.
Yes, let's take the example of a Toyota Fielder. Someone driving a 2008 Toyota Fielder internal combustion engine with an engine of about 1.5 and a CVT transmission, if they drive quite well, if they are tactical in how they are driving, they can achieve maybe 15, 16 kilometers or even 17 kilometers per liter of petrol, depending on how they are driving, whether they're on the highway and that kind of thing. But in the same circumstances, somebody driving a hybrid can achieve maybe 25, 24, something like 30% better fuel efficiency. So I think you can't dispute that. I mean, the numbers speak for themselves. That's why I say for someone to be convinced, they could, if they could get a test drive a hybrid vehicle for about a week and drive it the right way and find a comparable 100% internal combustion engine, it would convince them. Yeah.
That's very interesting too.
Yeah, but just expect maybe 20 to 30% better economy. And that's a huge figure.
Yeah, especially around here where the fuel prices can sometimes become, there are times when they shoot up so high. So those people with hybrids are really enjoying.
Yes, but when you hear, we are going to discuss electric cars in the next video. When you hear how the guys with electric cars are enjoying, you get, you'll be even more nuglicious. You have no on them. Yeah, we have about 3 minutes left. I don't know if you have any other comments. There's other stuff I'm thinking of talking about, but I'll wait until we are in the video talking about electric cars.
Briefly, can you touch on any disadvantages of hybrids?
Oh, yeah, there are a few, but it mostly depends on how you are using them. One disadvantage is that the batteries get old, so they may need to get replaced, especially because we drive used cars here. They come when they have like what, 100 kilometers, 100,000 kilometers on them. So you drive it for 5 years, the batteries start failing, so you need to replace them. So there could be a cost down the road for replacing the batteries. But like I mentioned earlier, that is manageable. They also don't like going through floods because the batteries are normally low on the vehicle to keep the center of gravity and the stability of the vehicle. So these things of driving through the floods in industrial area, electric cars and hybrid cars don't like that. But apart from that, but I mean, even when you discuss the batteries getting old and getting replaced, but so do the internal combustion engines. The mechanical parts of vehicles also fail. In fact, the engine can fail long before. The internal combustion engine can fail long before the batteries fail. So I don't even think that is a disadvantage. It is to be expected in any case. Yeah. So you can have an engine overheating and so on. And you can have mechanical issues with the engine 3 times before you even come to the batteries, depending on how you maintain the batteries. And I also need to caution people who buy the hybrids that the batteries mostly fail because of overheating, because the ventilation those batteries, when they are being charged, they warm up, so they need to be cooled. So the cooling system needs to be unblocked. And the way we drive here with the windows down, letting dust into the internal of the car, it clogs up the fan, and there are so many other things. So just be cautious. Read the owner's manual when you get a hybrid to understand exactly what the do's and don'ts. So sometimes we are going to blame the cars when it is us who are misusing them, who are abusing them. And they will fail accordingly. Yeah. So thank you very much, Alan, for your time.
Thank you.
Yeah, we are going to discuss the electric cars next. Thank you very much.
You're welcome.